Hey guys, welcome to Pre-calc Lesson 1.8, Writing Piecewise Functions. You'll be happy to know this is the last lesson of the first unit. Let's get started here. We're going to do a warm-up. I'm not going to go through this now because it's already, you have access to it on YouTube. It should be in your notes. But what I want you to do is remember or sketch all the base functions from day one. So that's this. I'm just copying that page of notes. So the parent functions are linear, absolute value, quadratic, all of these being able to identify 3 key points on every one of these. There's 9 total, know them by name, know them by shape. And we've been dealing a lot with the inverse graph lately and square root graphs, absolute value, quadratic, linear. Those are probably the most common, especially when we talk about piecewise functions. But you can't rule out a cubic or a cube root. Probably won't see a lot of exponential or log graphs yet. We'll get into those a little bit more in units like 4 and 5. Okay, so let's do a quick review of a piecewise function, evaluating and graphing. So first thing I want you to do here, given this piecewise function f of x, is x squared plus 3 when x is less than or equal to 0. Its absolute value, x minus 1, when 0 is less than x is less than or equal to 4, and it's the constant 2 when x is greater than 4. First thing I want you to do is evaluate f of negative 2. Well, remember, you don't plug it into all 3 of these. It's just going to be plugged into one. Which piece? That depends on what number this is and where it falls in relation to these 3 intervals. So negative 2 obviously is less than or equal to 0, so we're going to plug it into that function right there. So this is going to be negative 2 squared plus 3. Negative 2 squared is positive 4. 4 plus 3 equals 7. Our next one, 3. Where does that fall? Well, it's not less than or equal to 0. Is it between 0 and 4? Yes. So I'm going to plug it in here. Absolute value x minus 1. Absolute value 3 minus 1. That's 2. Absolute value of 2 is 2. So I just evaluate those two algebraically. Now I want you to sketch the graph. First thing I like to do is identify where this changes at 0. So it's going to change from one piece to another. It'll change from that quadratic to the absolute value. And then at 4, so x equals 4, it'll change from the absolute value to this constant. Now, one thing you might want to do here, and it doesn't matter what order you sketch these pieces as long as they're sketched correctly, I like to identify the easier pieces. So for me, this one's going to be easy, right? It's a constant, it's 2, greater than 4. So I'm going to sketch that in right now. X is greater than 4, so I'm going to go over 4. 1, 2, 3, 4. And it's going to be the constant 2, and that's an open circle. Okay, so I'm going to sketch that piece first, because remember, it changes at 4. This isn't too bad. Let's go to the quadratic. That's been shifted up 3. All right, and this made it kind of nice because notice there's not a horizontal shift here, and this is x is less than or equal to 0. So what I'm going to do for that is I'm going to go up 3, 1, 2, 3. That's the vertex of the parabola, so you should remember the pattern. Over 1, up 1, over 2, up 4, and I can't fit any more in this grid, so it's going to kind of look like that. Okay, so that's this piece here. And lastly, I've got this absolute value that's shifted right 1, and it goes from 0 to 4. So right 1, that's going to be the vertex, and it's going to go up 1 over 1, up 1 over 1, up 1 over 1. Now notice, you got to be careful here. This is a closed circle, and it's not this point. So that's going to remain open, and I have a closed circle right here. So there's that piece. And then again, notice that's going to be an open circle, and I'm going to go this way, and it has to be very clear that it's an open circle. And I've just sketched that piecewise function. So what we're going to be doing today is I'm going to give you a picture of a graph, looks like this, and you have to write the piecewise function. All right, let's start. Okay, so I'm looking at this piecewise function, and again, it's a function, so you have to use function notation. I'm kind of boring if I'm making one up. I always use f of x. To me, it's obvious. This is piecewise. I've got 3 different pieces here. So next thing I'm going to do is use a big set of braces. And I like to get the intervals of the domain first. So I can see here, one of these is going to be when x is less than -3, less than or equal to, because that's closed. Between -3 and 2, that's going to be this piece. And when x is greater than 2. So I'm going to write those down first. X is less than or equal to -3. That's going to be this piece. The other one's going to be when x is between -3 and 2. So I've got -3 is less than x is less than or equal to 2. Make sure you get those inequalities correct. That's just less than because that's an open circle. That's less than or equal to because that's a closed circle. And then the last piece is going to be x is greater than 2. Again, open circle because that's open. And there it is, greater than 2. What we have to do now is we have to write the function for each interval. So I've got 3 of them. This one's going to be nice. This is a constant, and this is going to be the interval when x is less than or equal to -3. So you just have to count. 1, 2, 3, it's -3. That function is going to be -3 when x is less than or equal to -3. Next one, again, you should recognize this. That's absolute value. We have to just make sure we're not doing any sort of vertical stretch, over 1, up 1, over 1, up 1. No vertical stretch. Notice the vertex is 0, 0. No horizontal shift, no vertical shift. This is just going to be absolute value of x. Now, the last one's going to be a little tricky. All right, I'm going to show you 2 possibilities here. The first one, you probably recognize, this is linear. Okay, so if it's just a line, what I need to do is get the slope and the y-intercept. Well, the slope's not bad. Up 2 over 1, up 2 over 1, so 2 or 2 over 1. But here's where some students will make a what I call a silly mistake. The y-intercept is not this value. Remember, you have to imagine that goes all the way back to the y-axis. That y-intercept is actually 1. Even though you don't see that, even though it's not part of this interval, that's what the y-intercept of that line is. So that's going to be 1. So this piece is going to be 2x plus 1. Slope is 2, y-intercept is 1. So that's a piecewise function that would graph what you see here. I'm going to show you another approach to this piece here. And some students find this a lot easier. Some students visualize this not as a line, but as an absolute value that kind of got cut off, where this would be the vertex. So you have to think to yourself, okay, well, if this is the vertex, what did I do? I went right 2, and I went up 1, 2, 3, 4, 5. Right 2, up 5, and it's got a vertical stretch of 2. So you could replace, let me use a different color here, you could replace this with 2 times the absolute value, x minus 2, close the absolute value, plus 5. Now, in my mind, that's more complicated, but some students will prefer, some of you will prefer, I should say, to do an absolute value where that's the vertex. Okay, let's practice a few more of these. All right, once again, easy to see. I've got 3 pieces. So let me start with my function notation. F of x equals. And my intervals of the domain, this is going to be one of them here. So that's going to be x is less than, it's open circle, x is less than 0. So comma, x is less than 0. And then I've got one between 0 and, what's that, 1, 2, 3, 4. Between 0 and 4, and notice closed circles. So I'm going to write that. 0 is less than or equal to x is less than or equal to 4. And then it looks like my last piece here is going to be x is greater than 4. So those are just the intervals of the domain. Those don't represent what the functions are, just where they occur. And again, you don't have to do these in any particular order. You just have to make sure that if you want to do this one first and write that function, that has to go in this interval. I usually like to start with my easier ones. That's just a constant. So that's 1, 2, 3, 4, 5. -6 is the constant, and that occurs when x is greater than 4. So that's going to be -6. This one's pretty nice. That's just linear. All right, so let's see. What's my slope here of this one? -2/1. The y-intercept is actually part of that. 1, 2, 3, 4, 5. B is 6. That's the middle piece. That's going to be -2x plus 6. This one's probably the hardest, but when you take a closer look at it, it's really not that bad. That looks like half a parabola. Is that the vertex? It seems like it, right? Left 1, up 1. Left 2, up 4. Left 3, up 9. Yeah, that's your classic pattern for a parabola. No horizontal or vertical shift. No vertical stretch. So that's simply x squared. Now, if you weren't 100% confident, what you could do is you could just double check. Let's say this linear piece in the middle, you're not quite sure. So let's say I'm going to plug in a 1 for the x. I'm going to plug in a 1 right here. All right, so what's that? 2 times 1, or sorry, -2 times 1 is -2 plus 6. That should be 4. Sorry. So 1, 2, 3, 4. Yep, that works. So you know this function matches that piece. All right, last couple here. I'm going to go through a little bit more quickly. What you should probably do is maybe pause the video, try and come up with the piecewise function on your own, and then just resume the video and check to see that you did it correctly. So we got f of x equals 3 pieces. One of them is going to be x is less than 0. One of them is going to be between 0 and 4. Again, looks very similar. So that's 0 is less than or equal to x is less than or equal to 4. And the other one's going to be x is greater than 4. This is going to be x squared. This is going to be -4. So the only thing that's different really is this middle piece. That's an absolute value that's been shifted 1, 2, 3 to the right. It hasn't been shifted up or down, and there's no vertical stretch. So that's just an absolute value shifted 3 to the right. So that's going to be absolute value x minus 3. All right, so if you came up with those 3 pieces in those 3 intervals, great job. This one we only have 2, okay? And there's a couple ways you can write this one. Again, a little bit interesting. You notice here breaks at 0. So if you're creating this function, it only has 2 pieces. One of them when x is less than 0. The other one when x is greater than or equal to 0. Now, we haven't really worked with this one a whole lot, but it looks like it just stops there. Now, if you think of what this function is, this is a square root function. Okay, so even though I say x is less than 0, it's not going to exist over here because the square root function itself is not going to exist. What we did is we moved it left 4. So that's going to be square root x plus 4. Again, if you're not 100% confident if you wrote that correctly, just check points. All right, so 1, 2, 3. I'm going to put in a -4. -4 plus 4 is 0. Square root of 0 is just 0. Well, yeah, that makes sense. -4 is 0. That works. How about this point right here? -3, 1. So I'm going to put in a -3. -3 plus 4 is 1. Square root of 1 is 1. And that's what I got right there. Finally, put in a 0. You should get a 2. 0 plus 4 is 4. Square root of 4 is 2. So I know it checks here, checks there in that open circle. I'm good. The other piece is simply linear. My slope is up 1 over 2, and the y-intercept is 1, 2, 3, 4, 5, 6. So that's simply going to be 1/2 x plus 6. Again, some of you guys might prefer to swap that out if you like thinking of everything as absolute value. So this could be an absolute value that has a vertical stretch of 1/2, because now it's over 1 up 1/2, has been shifted up 6. So you could replace the 1/2 x plus 6 with the absolute value, should say 1/2 absolute value, x, and then up 6 plus 6. You just have to be careful that plus 6 is outside of the absolute value because it's a vertical shift, not a horizontal shift. And the last one. Yes, last one. All right, 3 pieces again. F of x equals, and let's see here, looks like -2. So I've got less than -2 is that piece of the domain. X is less than -2. I've got between -2 and +2, closed circle here, open circle there. So that interval is going to be -2 is less than or equal to x is less than 2. And the last one, you notice, is a closed circle. So that's going to be x is greater than or equal to 2. So again, it doesn't matter what order you find these pieces. Just make sure you put them in the appropriate domain. So this is a constant. That's just going to be 1, but you have to put it between -2 and 2. That's just 1. This piece here is linear. Okay, so let's see, my slope looks like it's up 1 over 1, up 1 over 1. So slope is 1. Again, be careful. This is not the y-intercept. The y-intercept is this value here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the y-intercept is 9. The equation of that line is going to be x plus 9. Then our last one, it looks like a parabola. Let's check the pattern. If that's the vertex, over 1, up 1. Yep. Over 2, up 4. Yep. And you can't really check the last one. But basically what I did is I shifted it right 2. So that's going to be x minus 2 squared. Again, notice where you put that -2. It's got to be inside the parentheses, because if it's outside, there'd be a shift down 2, not right 2. Okay, so that concludes writing the piecewise functions from the graph. You guys are going to have a review and a work session to practice before the test. But again, any class time, any Zoom time, or through email, Brave Square, please send us any questions you have. Thanks for hanging with us this whole unit, and good luck on the upcoming exam.